We're going to be doing problem 26-1 today, and I'm going to be sharing my screen with you. So if you'll bear with me for just a second while I get the screen brought up. Okay, you should be able to see problem 2601B on your screen now, and what we're going to be working on is present value analysis, and also we're going to be working on the average rate of return method today. What we've been doing in chapter 26 is we've been looking at potential investments that companies would want to make in certain assets. And we've been looking at ways to evaluate whether or not these would be good investments for the company. So in this particular problem that we're going to be working today, in 2601B, we're going to be the Ellis Transport and Storage Company, and we're going to be considering two types of investment projects, and those investment projects are going to be whether the company will want to invest in a warehouse or whether they're going to want to invest in tracking technology. And so what you can see here is that the assets have listed what we are expecting them to return to us as far as our income from operations. This would be the average amount of the income that we would be expecting in each one of these years. These are just estimates of the income that we would make off of that warehouse if we were to invest in that warehouse. But it will also help us to be able to evaluate whether we should invest in the warehouse or whether we should invest in the tracking technology. So notice they've given you for the warehouse the income from operations for year 1 through 5. This warehouse has a useful life of 5 years. That's what they've estimated the life of this warehouse to be. And you can see that they also have estimated the amount of cash flows that they would be expecting to receive from this investment in the warehouse. So the cash flows that this investment is going to provide for this company are given for years 1 through 5, the life of the asset, and these are the cash flows for the warehouse company. Also, for the second investment that we're going to be looking at, the tracking technology, they too have given us the estimated amount of income from operations for each of the 5 years of the life of the asset, as well as they've given us the estimated amount of cash flows for the tracking technology. One thing I'd like to point out to you is that when you're looking at the net cash flow for the warehouse company, you can see it's not the same every single year. And so what that tells me is that if we are to apply present value analysis to this asset, that we would have to use the present value of the dollar table. And that table is given to you down here. Because the tracking technology has equal amounts of cash flow, we could have possibly used the present value of the annuity table to determine the present value of tracking technology. But unfortunately, in this problem, they didn't give you but one table to use. So I'm going to show you tonight how to use the present value of a dollar table, our lump sum table, to calculate the cash flows in each year for each of the investments. And then we're going to compare that present value to what we have are going to initially pay for the asset, and the difference will be the net present value. But before we do that, what we're going to be doing is the average rate of return on each one of these investments for the warehouse. Now, when you're determining the average rate of return, it's really important that you know the formula for preparing the average rate of return. So if you will, please, I want you to jot this down in your notes. The average rate of return is calculated by taking the estimated average annual income and dividing it by the average investment. Now, once you do that, that will give you the average rate of return. But when you're determining the estimated average annual income, the numerator portion of this formula, you will need to determine the total amount of the income that you are expecting to receive off that investment. And in this case, they've already totaled it for you. They're expecting to receive $172,000 for the warehouse. What you would do to find the numerator, which is the estimated average annual income, is you would take this 172,000 and divide it by its useful life. So I'm going to pull up my calculator, and I'm going to pull it over here to where you can see it. And I'm going to take the warehouse income from operations, the total amount for the 5 years, which was 172,000. I'm going to divide that by the life of the asset. The life of the asset is 5 years. That's the useful life of the asset. And what that will do is that will give me the numerator portion of the average rate. This numerator is called the estimated average annual income. So write down the estimated average net income, or the estimated average annual income of $34,400. And then I want you to divide that by the average investment. To calculate the average investment, we need to know how much the asset is going to cost us. We also need to know what the residual value or the scrap value of that asset is going to be at the end of its useful life. In this first problem, there was no residual value at all. The residual value is 0. So to determine the average investment, you would take the cost of the investment, which is going to be $368,000, and you would divide it by 2 because there was no residual value. If there had been a residual value, you would have taken the $368,000 and added the residual value to that, and then divided it by 2 to get the average investment. So there are really 2 parts to determining the average rate of return. The numerator part we just found was 34,400, and that's what we call the estimated average annual income. And what we'll have to do is divide this amount by the average investment. To find the average investment, it was 368,000. That was the cost of the investment. And because there was no residual value to add to it, we'll just simply divide this amount by 2 to get the average investment amount. This 184,000 is going to be divided into the 34,400. So I'm going to take my 34,400, which was my average annual net income. I'm going to divide that by 184,000, which was my average investment. And what that's going to give me is a decimal form of the percent that would be the average rate of return. Now, in your instructions, they tell you to round your answer to one decimal place. So this would be 18.7% is the amount of the average rate of return. I would want to do the same thing. I would want to find the average rate of return for my tracking technology so I could compare the two assets to see which one would give me the higher rate of return. So with the tracking technology, you can see that the income from operations, the total amount for the 5-year life is 172,000. That's exactly the same as it was for the warehouse. So the numerator portion would be 172,000 divided by 5. It'll be the same thing that you found for the warehouse. So 172,000 divided by 5-year useful life will give me 34,400. Also, with the tracking technology, it's going to require an investment, a cost of 368,000. And again, there was no residual value. So we would simply take the 368,000 and divide it by 2 to get the average investment. So just like the warehouse, it just so happens that the tracking technology, the average rate of return on this investment is going to be exactly the same as the warehouse because the income from operations was the same and the amount that we are investing in this asset is also the same. So this 34,400 would be divided by 184,000, which will give you the very same thing that we got a while ago, which is 18.7% as the average rate of return on the investment. So if we were evaluating this proposal, both of the proposals have the same average rate of return, so we would move to another form of measurement to evaluate the warehouse and the tracking technology further. And so that's where we're going to move to the part of this problem where they have you calculating the net present value of each one of the investments. So we've subject these investments to the average rate of return, which just so happened to give you the same amount of the average rate of return. So we're going to have to choose another way to evaluate these investments. And so we're going to use the net present value to determine which investment that we should choose. In the first part of determining the net present value, you have to determine the total present value of the net cash flow for the warehouse. And so when we are calculating present value, one of the things that I would write down if I were a student is that we always use just the cash flows for the analysis. So for the warehouse, you can see that they have given you the net cash flows for each one of the 5 years. Each one of these 5 years is we are going to have to calculate the present value for each one of those. Again, I would suggest that you write this down because there's going to be a lot of calculations in determining what the present value will be for the warehouse. We would be looking at each one of the 5 years separately. So what you're going to do is you're going to need to read your problem to see what the selected rate of return, or excuse me, the selected interest rate is going to be for the net present value analysis. The interest rate is 15%. And so we're going to take the warehouse, we're going to start with it first. The very first net cash flow of $135,000, we're going to multiply that by the table value for 15% interest for the first year, which is 0.870. So we're going to multiply this 135,000 times 0.870. That's the table value at 15% for 1 year. And when we multiply that, that will give us the amount of the present value of the cash flow in the first year. The present value of the cash flow in the first year is $117,450. Again, we took $135,000, we multiplied that by the table value amount for the first year at 0.870, and that will give you the present value amount of $135,000 in year 1. The second year, we're expecting a net cash flow of $125,000. So I'm going to take $125,000, my net cash flow, and I'm going to multiply that by 0.756. We would go down to year 2 because this is the second year's cash flow. We go across the table to 15%, and we would pick up 0.756. So I'm going to multiply the cash flow by 0.756, and that will give me $94,500, which is your present value for the second year. So $125,000 in year 2 has a present value amount of $94,500. In year 3, we have $110,000 that we think that we're going to be receiving in cash flows off of this investment. So I'm going to start by taking my $110,000, and I'm going to multiply that by the third year's present value factor, which is 0.658. So I'll multiply 110,000 times 0.658. And what that will give you is 72,380. So on the fourth year, we have cash flows that we are expecting from the warehouse at 100,000. So I'm going to take 100,000 and I'm going to multiply this by the fourth year's table value amount at 15%, which is 0.572. So I'm going to multiply this by 0.572, and that will give you 57,200. That is the present value of 100,000. To find the fifth year's present value, I'm going to take 70,000 and I'm going to multiply that by the table value amount at 15% for the fifth year, which is 0.497. That will give you 34,790 as your present value of $70,000. Now, once you have the present value of each one of these cash flows calculated, you have to add all of them together for the year to get the total present value of the net cash flows for the warehouse. So I'm going to start with year one. The present value was 117,450. I'm going to add to that 94,500. I'm going to add to that 72,380. And I'm going to add to that 57,200. And I'm going to add the present value for the fifth year, which was 34,790. And what that will give you is a total present value for the warehouse at 376,320. Now I'm going to move over to tracking technology, and I'm going to figure out the total present value for tracking technology. As you can see, the tracking technology in year one was expecting a cash flow off of this investment of 108,000. So I'm going to take 108,000. I'm going to multiply it by 0.870 because this was the year one net cash flow at 15% for one period, or 1 year, I should say, is 0.870. So 108,000 times 0.870 is going to give you 93,960. So the present value of the net cash flow for year one is 93,960. For year two, we would take the year two's net cash flow, which was 108,000. You would multiply it by the second year's present value amount of 0.756. Let me put that in the calculator again. 108,000 was your cash flow times 0.756. That's the second year's table value amount, and that will give you 81,648 as the present value in year two. I'm going to go to year three. It just so happens year three is 108,000 again. So I'm going to take 108,000 but I've got to multiply that by the table value amount for year 3, which would be 0.658. And that will give me the present value in year 3 of $71,064. In year 4, I would take the 108,000. I would multiply that by the table value amount for year 4, which was 0.572. And that will give you 61,776. Then in the last year, I would take 108,000 and I would multiply that by the table value amount for the 5th year, which was 0.497. And that will give you 53,676. Once you have each year calculated separately, you'll want to total those, and the grand total is in the tracking technology. So for year 1 tracking technology, the present value of 108,000 for year 1 was 93,960. We're going to add that to the present value for year 2, which was 81,648. And we're going to add to that year 3's present value, $71,064. And we're going to add to that the next year's present value at 61,776. And then finally, in the 5th year, was 53,676 was the present value amount. So the total amount is going to be 362,124. And so what this did is this gave me the total present value of my tracking technology. Then what I want to do is I want to write down the amount to be invested. That's going to be what the investment is going to cost us. The investment cost is given to you. Each project was going to require $368,000 as an investment. So I'm going to put down $368,000 as the cost of this investment. And it's also the cost of the tracking technology. Both of them had the exact same cost. Now, determine net present value. And to do that, we're going to subtract our initial cost from the total present value, and the difference will be the net present value amount. So 376,320 is the present value, the total present value of the warehouse. We're going to subtract the cost, which was 368,000, and that will give you 8,320. The total present value for our tracking technology is 362,124. I'm going to subtract out what it's going to cost me, which was 368,000. I have here is a negative net present value amount. So I'm going to put it in as minus 5876. And that's my net present value of the tracking technology. And so what this tells us, class, when we're comparing the two of these, is that our warehouse has given us a positive net present value, which is certainly better than a negative net present value. So the warehouse would probably be the better choice for this investment. So in part 2, they ask you a question to fill in the blank. The warehouse net present value exceeds the selected rate established for discounted net cash flows of 15%, while the tracking technology does not. Thus considering only quantitative, which means it's numbers that we're evaluating here, the factors, the investment that we should select would be the warehouse. And so what you're doing, class, you're just trying to evaluate between the two investments, which one would be the better investment. As you can see, with the average rate of return, they both were neck and neck on that part. So we would have to subject the investments to further analysis. And so we did that with the net present value analysis, and then it was determined that the warehouse would be the better investment from these investments. There's a lot of calculations in these. And again, when you're determining present value, it has to be on your net cash flows. Now, one of the things that you might run into as a obstacle when you are doing some of your homework problems is you may not know which table to use. And the way that I can tell you which table to use is by looking at the net cash flows. If they're unequal, you have to use the present value of a dollar amount compound interest table to get your present value amounts. If they are equal, you could have used the present value of the annuity table to determine the present value of the equal payments. But in this particular problem, they didn't give you an annuity table to use. So you had to do it the long way and calculate each one of these years' net cash flows separately, find the present value in each year separately, and then combine it all together to get the total present value. Okay, so I'm going to move to the next problem, which is 2605B. And in some ways, it's going to be similar to the problem that we just did. The only difference is we're evaluating two different investments, and the investments have different useful lives associated with them. And so in this company, we're evaluating two restaurant sites. One's going to be in Wichita, and the other one is going to be in Topeka. Each have different useful lives, but each requires the same initial investment or the cost of $900,000. The estimated net cash flows are what are given here, so we're probably going to do some present value analysis. It says the committee has selected a rate of 20% for purposes of net present value analysis. So they're going to want you to use a 20% interest rate. It also assumes that the residual value at the end of each restaurant's useful life is going to be 0. But at the end of the 4th year, Wichita's residual value would be $500,000. So residual value is the scrap value, and that's the value that we think that we would be able to sell this asset for. So if we are evaluating these assets, you want to look at your directions carefully in this particular problem. First of all, it says for each site, compute the net present value, and they want you to use the present value, the annuity table below. And they also want you to ignore the unequal useful lives of the projects. And if required, you're going to round to the nearest dollar. So what we're going to determine first is the present value. This time we're going to use the present value of the annuity table because our cash flows are the same throughout the life for Wichita. Cash flows are the same at $400,000 for the Topeka. So because these are equal amounts, we can use the annuity table. So we're going to cross this table off and not even look at it in the first part of this. But what we do need to know is that there's a 20% rate of interest that they believe they can get off of their investments. So we're going to be using the 20% present value of annuity table to get the present value of the annual net cash flows. Let's start with the Wichita Company first. Notice Wichita Company has a useful life of 6 years, and they also have a series of equal cash flows, which means that that's an annuity. We're going to use $310,000. So in our calculator, I'm going to go ahead and put in $310,000 because that's the cash flows in each one of these years. Now listen carefully to what I'm going to do here. Because Wichita has a 6-year life and they're wanting a 20% return on annuity, I'm going to go down 6 years. I'm going to go across to 20%. My table value amount is 3.326. I'm going to take that 310,000 and I'm going to multiply that by the table value amount because there were 6 years in the life at 20% interest. The table value amount is 3.326. So the present value of the Wichita is $1,031,060. Now, class, be careful here. When you're using the present value of the annuity table, you only have to multiply one time to find the net present value because all of these amounts for Wichita are equal. So again, I took 310,000. I went on my table. I'm going to look at the present value of the annuity table. I'm going to go down 6 years and I'm going to go straight across to 20%. My table value amount was 3.326. I multiplied that 3.326 times 310,000, and that gave me the present value for the Wichita location. Now for Topeka, there's a difference. Notice that Topeka only has a 4-year useful life. Also notice that they're expecting $400,000 in cash flows. So I'm going to put 400,000 in my calculator. I'm going to go down my table for 4 years, and I'm going to go across to 20%, and that's going to give me 2.589. I'm going to multiply this 2.589 by the 400,000, and that's going to give me a present value for the Topeka company at $1,035,600. Again, because Topeka only had a 4-year life, I had to look on my annuity table. Since all these payments are equal, all these cash receipts are going to be equal. 4 years at 20% interest is 2.589 that I multiplied by 400,000 to give me Topeka's total present value. Then what I've got to do is I've got to look to see how much the investments are going to cost us. And in the first line of this problem, they told you that each investment was going to cost $900,000. So 900,000 goes here in each one of these. And then to find the net present value, I'm going to subtract my amount invested from my total present value. $131,060 is my net present value for Wichita. For Topeka, I'll take my total present value and subtract out 900,000, the cost of the asset, and that will leave me with 135,600. All right, so it looks like Topeka is the better investment if you ignore the unequal lives of the projects. For part 2, we're going to also compute the net present value, assuming that Wichita is adjusted to a 4-year life for purposes of analysis. So we're going to try to look at this from the standpoint of if we've got two investments that we're looking at, and one of the investments has a longer useful life than the other one, if we shorten that useful life of the, in this case, the Wichita company, because it has the longer life associated with it, what if we shorten that useful life to 4 years? Now, what you have to remember is that they gave you some additional information that said that it estimates the residual value at the end of each restaurant's useful life as 0. However, it also states here, but at the end of the 4th year, Wichita's residual value would be $500,000. So in this situation, that $500,000, we are expecting that we could sell the asset for the scrap value of $500,000, and that would give us some extra cash that would be associated with the Wichita company. And because the $500,000 is not equal to the $310,000, that means that our net cash flows for the Wichita investment will be unequal. The first 4 years, they are equal at $310,000 that they're expecting in net cash flows for each of the year. But at the end of the 4th year, they think that they could sell the asset for an additional cash flow of $500,000, which is not equal to $310,000. So that means we have to use the present value of the dollar table to determine the present value amounts for this. They also have told you to use the present value of the dollar table in part 2 of this problem. But that's the reasoning behind it, because the Wichita's amount would no longer be the equal amounts. They will be unequal because at the end of the 4th year, we could expect to receive cash of $500,000 if we sold the Wichita investment. So listen carefully and write this down. Start with year 1 of Wichita, which was $310,000. You'll want to find the present value of that year 1 $310,000 cash flow using the present value of the dollar table. That was the first table there. The rate is still going to be 20%. It's year 1, so we're going to multiply 310,000 times 0.833, and that will give me the present value of 310,000 at year 1. You're going to do the same thing for year 2, except the 310,000 would be multiplied by year 2's table value amount, which is 0.694. So I would take 310,000, I would multiply that by the second year's table value amount at 20%, which would be 0.694. And that will give me the present value for year 2 of the Wichita company as being $215,140. For year 3, we're going to pick up 310,000. We're going to multiply that by the third year's table value amount, 0.579. And that will give you 179,490. That's the third year's present value amount. In the 4th year, we're going to take the 310,000. We're going to multiply it by the 4th year's present value table factor. The present value table amount factor was 0.482. In year 4, the 310,000 present value would be 149,420. Now, because we are working on part 2, you'll remember it said to adjust the Wichita location to a 4-year life. And we have found the present value for each one of the years for 4 years. But at the end of that 4th year, there would be a residual value of $500,000. There's another cash flow that we could expect if we sold the asset for its residual value of $500,000. So we will have to calculate the present value of $500,000 at the end of year 4. So we're going to multiply this by the present value table factor for 4 years at 20%, which is 0.482. That 500,000 times 0.482 will give you the present value of 500,000, which is 241,000. Then we're going to determine the total present value for years 1, 2, 3, and 4 with the extra $500,000 cash flow that we are expecting from the Wichita investment. So in the first year, the present value of $310,000 was $258,230. We're going to add to this the present value in year 2, which was $215,150. In year 3, the present value was $179,490. In year 4, the present value of $310,000 was $149,420. And then also at the end of year 4, the present value of $500,000 was $241,000 that we're going to add to this. So the total present value may have a mistake here, but let's see. It's 1,043,580. I didn't add them right. So I'm going to go back and I'm going to add them again. So we're going to have 258,230, which was the first year's present value amount. I'm going to add to that 215,140, which was the second year's present value amount. I'm going to add to that 179,490. And I'm going to add to that 149,420. And then I'm going to add 241,000. And that's going to give me 1,043,280. Okay. Now, for the Topeka company, they want you to determine the present value of the Topeka company. Now, in reality, you probably could have just used the figure that they gave you or that you found up here with the present value of the annuity table. But for some reason or another, I don't know why exactly, when they calculated their present value of the annuity dollar tables, some of these were not rounded in the same way. So there's a little bit of a rounding error. So you're going to get the wrong answer if you don't use the present value of a dollar table. So in the second example, even though Topeka's cash flows are 400,000, in order to make Cengage give you the right answer, you're going to have to use the present value of the table and make all those calculations separately. So we're going to start with year one, which was 400,000. We're going to multiply that by year one's 20% rate, which was 0.833, and that would give you 333,200. That's in the first year. In the second year, for the Topeka company, the cash flow was 400,000 again. So we'll take 400,000. We will multiply that by 0.694. And that will give you the present value of 277,600. In the third year is 400,000 again. And we would multiply that by the third year's table value amount, which is 0.579. And that will give you 231,600 as the present value for the third year. And then in the fourth year, we would take the 400,000 and we will multiply it by the fourth year's table value amount, which was 0.482. And that will give you 192,800. And then to find the total present value, we would add each one of those years that we calculated the present value for together. In the first year, it was 333,200. We're going to add to it 277,600 for the second year. For the third year is 231,600. And for the fourth year, it was 192,000. $800. And when we add all those together combined, it'll give you $1,035,200. So $1,035,200 is going to be the total present value for the Topeka company. We're going to subtract out the amount that was invested, and again, that was given to you. It was still $900,000. It's given to you in the first line there. And then you're going to determine the net present value by taking the total present value for Wichita and subtracting out $900,000. And that will leave you with a net present value for Wichita of $143,280. And then we're going to do the same thing for Topeka. We're going to take the total present value and we're going to subtract out $900,000. And that's going to leave you with $135,200. So in this case, when we look at this, Wichita came out ahead in the game. So when we're using the net present value, the two sites over the equal lives, which was in part 2, it indicates that Wichita has the higher present value and the superior investment. And so this is how you would evaluate those two proposals. If you evaluated it using the net present value with unequal lives, Topeka would be your better answer. But if you shorten the life to make them more equal in nature, if we shorten Wichita's life to 4 years, then we had to take in consideration that there was an extra cash flow for the scrap value if we sold a particular asset. So these are ways that we can evaluate our assets or our investments, and that's what this chapter is about. So I'm going to stop sharing now, and I'm going to stop the recording.